Hey guys, thanks for joining us. This is packet number 3. So we do turn in our notes, so make sure it looks like I left off the name line. So go ahead and add that there. Type in your name, the date, and the period. This should be period 1 or period 6. Okay. So we have, this first one is on polynomials. It looks like in one of my classes I took notes here, so you guys can kind of take notes on here if you missed this part. I think in period 1 we had a little shorter class because we retook a few stickers. Okay. And then we did this in class. I think we did pretty much the same examples together. And then we did this one in class. I think my other class did example 7. You can take notes on those. Pause the video if you want, if you're interested. If not, you can just leave what we did together. Okay, so let's go back to the new section. We're going to do this one here. It says the area of a rectangle is given as such. What are the lengths and widths of the rectangle? Okay, so this is telling us to factor. Okay, so we have, this is 11 and this is 28. So we need to know what multiplies to give me 28 and adds or subtracts to get me 11. So 28 is pretty interesting. So we do 28 divided by 2, we get 14. 28 divided by 3, we get a decimal, right? So we're just crunching this in our calculator. 28 divided by 2, 14. 28 divided by 3, is a decimal. 28 divided by 4, we get 7. Ooh, 28 divided by 4 is 7. I think I like it because 4 and 7 make 11. Okay, so what must this look like? We know that this is x plus 7 and this is x plus 4 because when we multiply them, we get x times x, which is x squared. When we multiply these terms, we get 28. And when we multiply these inside terms, we get 7x and outside terms 4x. So those would add to give me 11x, right? Okay, so what is the width and what is the length? I don't think it matters. Okay, I'll just put one of these is width and one of these is length. So this was an interesting way to ask how to factor. Okay, let's do number 2. It says choose a list in which all the common factors are 36 and 24. All right, so it looks like this picture must go with this one. Okay, so we're not going to use this picture. We're just going to do common factors. So what is factors? That's what we did right there. So if I had to divide 36 divided by 1, I get 36. So 1 and 36 is a factor. 36 divided by 2. I get 18, right? So 2 and 18. So they want to know common ones. Which ones do they have in common? So let's see. 24 divided by 1. 24 divided by 2. So I think it might be easier to find, well, which ones do they not share in common? And then we can eliminate, because like here, the number 8, I don't think they both have 8 in common. So let's try that out. 36 divided by 8, we get 4.5. So since this is a decimal, that means it's not a factor. Okay, so we've eliminated that. Now, this list, 1, we know that's a factor, right? 2, 3, 4, 6, 12. This one, they left out 1. They also have this number 18. That looks a little big. Let's just say 24 divided by 18. 24 divided by 18, I get 1.3. Yeah, so I definitely do not like A. 1, it left out a 1, so I knew that was wrong. But that 18 is way too big to be a factor. So we find our answers here. B is correct. That's a factor of both. All right. Question number 3 says, evaluate, meaning plug it in. So where we see the letter X, we are going to plug in there. And we're going to be very careful using parentheses. All right, so we rewrite the problem. Okay, So we have, and we do the parenthesis part first. So when we have 4 times a negative 8, because negative 2 times negative 2 times negative 2 is negative 8, minus 3 times 4, because negative 2 times negative 2 is 4, and then we get 2. So we end up getting negative 32, take away 12 plus 2. Let's evaluate that in our calculator. All right, I get negative 42. Okay, now it says simplify these. Okay, so write it in its simplest way possible. So let's distribute or get rid of these parentheses. So we'll have 11 take away 3x minus 27 minus 4x plus 8. All right, now how many x's do I have? It looks like I have negative 7 x's. How many regular old numbers do I have? Looks like I have 11 take away 27 plus 8. So 11 take away 27 equals plus 8 equals, I get negative 8. So this is definitely writing it in a simpler form. All right, 5. What operation is not closed? Well, this is interesting. So notice we've been adding polynomials, right? 4x cubed minus 3x. We know we can add them. Subtract them. I just wrote a subtractor. I know I can subtract them. Multiply them. We just did multiplying them up top, didn't we? So what can't we do? We have a problem when we divide because it might not graph as a polynomial. So that's what they mean by not closed. So let's think about this just now. If we took one of our polynomials and we divided it by this one, notice we'd get an error in our calculator if x is negative 4. So this is our problem with not closed. It's a graphing problem. Okay, let's look at number 6. It says select all the polynomials that are equivalent to each other. That just means equals. Okay, so let's take a look. Let's start with the most simple one. Okay, so that's probably this one here, right? So you have x cubed, take away x times x, which is x squared, x times x, this times this, and then take away x times a negative 1, so that would change the sign, 1x. Then we could do this one and this one, right? So take away 1x, and then this last one, negative 1 times 1 is negative 1, but again, we distributed a negative throughout. All right, so what do we got here? This would cancel, giving us x cubed minus x squared plus 1. That's what we get. Now, is this equivalent to anybody else? That's what we're going to have to figure out. Okay, so this one, we could distribute our negative here, right? Negative 2x squared minus 3. Here, we have a 1 to distribute, and when you multiply anything by 1, it doesn't change it. So we can rewrite this just like this. And then same here, I have a 1 to distribute, which doesn't change anything. Okay, so we have this x cubed. Okay, so that's kind of a match, right? Do we have x squared? It looks like we do have 1x squared. Here I had a negative x squared, so that's different, isn't it? Yeah, so this is different. Okay, let's go ahead and finish up. I have an x minus an x, so that's the same. And then I have a negative 3 plus a 2, so that's a minus 1. So these are very similar, but they're different. Okay. Let's keep playing along. This has an x squared, but we have to distribute this x. So if we distribute this x, we'll get x cubed minus 2x plus 1 minus x squared plus 2. Here we have an x squared. Here we have a minus x squared. Okay, so it looks like these two might be the same, right? And then 1 plus 2 is 3. we got problems. Nope, those are not the same. They're different. So we get x cubed minus x squared hold on. I think I might have made a little tiny mistake here. When I distribute this, x times x, negative x times x, then I get positive 2x. Okay, there we go. So we equal x cubed, we got that. Negative x squared, got that. These cancel, okay, we got that. And then we have a plus 1. Ooh, we got that. Okay, I'm back in business. These are a match. So we just have to decide if this one is not. These two are going to match. And you know what? I'm going to cancel those out just because I'm out of room. So I think, and let's just say we simplified that question. So here we notice these two are the same and this one is different. Cool? All right, I'm just going to do 2 more problems. And if you want to know answers on some of the other ones, feel free to ask. I'm going to do question number 7 and then go ahead and do question number 10 because I like how they laid out. So what is the product of 4x times negative 3 squared? So that's 4x, okay? Now I can write it out like this, 4x minus 3 times 4x minus 3, right? Multiply these two, which would be 16x squared. Multiply these two, minus 12x. Then multiply these two, minus 12x. Multiply these two. Excuse me, plus 9. So I get 16x squared minus 24x plus 9. All right, that's what I get. Where did I? That looks right. See that? So this is 4x times 4x. This is negative 3 times negative 3. And this is the combination of the 2 terms in this middle, the inside terms and this outside term. So some students like to do it in a box to help keep track of those 2 terms. So in the same way, we could write 4x minus 3 here, and we're squaring it, so it is a square. Its height and width is the same. We can multiply it. So in this box would be 16x squared because it's 4x times 4x. In this box would be negative 12x because it's 4x times negative 3. In this box, I also would write negative 12x because I have negative 3 times 4x. All right? And now in the last box, I'm going to make 9, right? Because negative 3 times negative 3 is 9. So we get these same terms, this, right? And these combine to make this. And they combine because they have like terms. Let's look at these same types of patterns, but with a more complicated question. So they wrote this here for us, very nice and handy, right? And they wrote this here in the box. And we're going to go ahead and multiply this through. Now, it's actually usually easier for kids to do the numbers first. So I'm going to do that first, right? We go 4 and 1 would 4 times 1 is 4, right? So this would be 4 times a negative 2x, so that'd be negative 8x. Now this next box is 4 times x squared, so that's 4x squared. So we notice this is the multiplication of these two. This is the multiplication of these two. This is the multiplication of these two. All right, now let's take it the next step. I'm going to multiply negative 3x by this, so that'd be negative 3x cubed. This would be positive 6x squared because it's negative 3x times negative 2x. All right, last one, it says negative 3x times 1, so that'd just be 1 negative 3x. It says complete the table and then write the answer in standard form. So what is standard form? It means I have to write all these out, but I have to combine the ones that are alike. So it looks like these are alike because they're both x squared, so I'm going to combine those. And standard form also says, oh, these are alike, right? They're both x's. And standard form also says I should start with the highest order of polynomial. So that means I'm going to start by writing it negative 3x cubed, then write plus 10x squared, right? Those are these blue ones that are alike. Then write negative 11x, then put my 4. This is in standard form. Thanks for joining us, guys. See you next time.